Okay, in this video, what we're going to do is this is a variation on a theme. And this is something else we can do with an acid-base titration, and that's determine the molar mass of an acid. Remember that molar mass is equal to grams of whatever we have divided by moles of the same sample. Okay, so how this is going to work is you have some sort of unknown acid. Okay, you're going to do a titration with sodium hydroxide, which makes this the titrant. Okay, this is going to do a neutralization reaction. It's going to give you the salt of the crap that's left over. All right, this is our salt, and it's going to give us water because we've used hydroxide as the base. Okay, ultimately, what we're going to need, what we're going to figure out is we're going to get the volume of sodium hydroxide that was added. Okay, and as we saw before in the previous video, the volume of sodium hydroxide added will lead us to moles of sodium hydroxide. What is with me? Moles of sodium hydroxide. The moles of sodium hydroxide will give us moles of acid, which in this case I've just dubbed it HA because we have a monoprotic acid. Okay. Once we have this is how we're going to get moles of acid. The unknown, we will probably know grams of the sample. Okay. So let's put this into practice and try out a titration problem with this. Okay. We have 0.1216 grams of monoprotic acid. It's dissolved in 25 milliliters of water. And then we're going to take this sample and titrate it with sodium hydroxide. And at the end point, we find that we've added 12.50 milliliters. This at the end point is what we have added. Okay, this was the volume we dissolved stuff into. This is how many grams of our unknown we have, and this is the concentration of sodium hydroxide. Okay, so our steps here is we need to figure out moles of acid. We'll do that first, right? Our unknown acid. We can do that using our equation. Since this is a monoprotic acid, we can say that our equation is the same as what we just had, that HA in solution reacts with sodium hydroxide in solution to give us NaA, aqueous, and some water liquid. Okay. When we have that equation, we can use, we can use dimensional analysis to figure out our moles. Okay, so start with the titrant. Always start with the titrant. So that's our sodium hydroxide. Okay, that's great. 12.50 milliliters of sodium hydroxide. We know that our sodium, well, nope, we got to get to liters so we can use our concentration. Once we have liters, right, 1 liter of this is 0.1104 moles sodium hydroxide. Okay, we probably determined that by doing a standardization. Let's see, moles of sodium hydroxide. We need our equation, excuse me, to get to moles of acid. So that's 1 mole of sodium hydroxide for 1 mole of acid. You can call it HA if you wanted to. Here we go. So now we can math this out. We got to moles, 12.5 divided by 1,000 times 0.1104 gives us 0.00138 moles of acid. This dude needs 4 significant figures. Okay. All right. So there's that part. The second part, what the heck? Sorry. Okay. Next thing we're going to need then is what? We have moles? No, we're almost done then. We need grams per mole to give us molar mass. These are the grams. We were given the grams at the start. So 0.1216 grams divided by 0.00138 moles means 0.1216 divided by that many moles means our molar mass is 88.115942 grams per mole. That's grams. All right. Four significant figures then. 88.12. I swear it's how I'm putting my hand. Grams per mole. All right. Does that make sense? Not too terrible. If you need anything, let me know. I'm here. I got your questions. I'll see you in class. Have a good one.